Hey everyone, welcome back. In today's tutorial, we're diving into building agent evals using Claude Code and the Eve framework. We'll cover everything from opening your project in Cursor, getting introduced to Eve agent evals, installing the package, and scaffolding your first eval project. Let's get into it. Build agent evals with Claude Code and Eve framework, full tutorial. In this tutorial, we'll cover opening project in Cursor, introducing Eve agent evals, installing Eve package, scaffolding eval project, configuring eval files, connecting project to Vercel, debugging scope errors, running first eval. Let's go. So here we're looking at a Finder window inside the Cursor IDE, and we're navigating to the Vercel or in directory to select a project folder to open. You can see there are a bunch of AI and agent related projects in here, things like Claude Loop Tutorial, Kale Agent, and Landgraph Gilliam Agent, which gives you a sense of the kind of work we've been doing. We're going to go ahead and click Open GUID to load this project directly into Cursor, which is where we'll be writing and running all of our code today. So here we've got Claude Code open in the terminal, and we're about to kick off our agent evals workflow by typing, "Hey Claude, let's get started with agent evals." You can see on the right we've got Eve's tweet showing off their Eve eval command, which runs evaluations against a local or remote agent and scores the results using LLM-as-judge. Pretty powerful stuff. We're going to use this as our reference while we set up the Eve agent evals project in Cursor. So here we're kicking off our agent evals journey by having Claude check out the Eve agent evals project. You can see it's running a shell command to inspect the directory structure and verify whether Eve is installed locally. On the right, we've pulled up the tweet from evadev that explains exactly what we're building toward. A framework where every eval runs against a local or remote agent and scores its responses using an LLM-as-judge. Before we proceed, Claude is actually pausing to ask us whether we want to auto-install EV via npm, which is a great safety checkpoint before making any changes to our environment. So here we're watching Claude actually read a tweet from the Eve developer account to understand what agent evals are. And notice it hit a 402 payment required wall because the tweet is paywalled. So it's smartly pivoting to install the Eve package directly from the bundled docs instead. We're running npm install Eve in the terminal, and Claude is asking us to confirm before proceeding. You can see it's giving us the option to say yes, yes, and don't ask again, or no. This is a great example of Claude operating autonomously while still keeping you in the loop on consequential actions, like installing new packages. So right away we can see our agent hit a bit of a snag. It tried to fetch that tweet from XCOM but got a 402 paywall error, so 0 bytes came back. No worries though, because the agent is self-correcting here and deciding to install the Eve package via npm install Eve and pull from the bundled docs directly as its source of truth. This is actually a great example of the agent reasoning through a dead end and pivoting on its own, which is exactly the kind of autonomous behavior we're building toward. So what we're seeing here is Claude attempting to scaffold our Eve agent evals project. It tried to fetch a tweet from the Eve dev X account, but you can see it hit a 402 payment required wall, meaning that content is paywalled. No problem though, because Claude is smart enough to pivot on its own. It's now reading directly from the bundled Eve docs at Eve, dev, docs, evals, overview, which is exactly the reference we need to understand how define eval works and how to structure our evals directory. So what we're seeing here is Claude acting as our agent. It's actually reading the Eve docs on the right while simultaneously scaffolding our project in the terminal on the left. Notice how it hit a snag with the silent Claude directory blocking initialization, so it's intelligently moving that aside, running npx eve init, and then restoring it. That's the kind of autonomous problem solving that makes using an AI agent for setup tasks really powerful. So here you can see Claude is doing something really clever. It's actually reading the Eve evals documentation on the right before writing a single line of code. It's checking for API credentials, inspecting the scaffolded files, and building a mental model of the eval system first. This is exactly the kind of methodical approach you want when setting up an agent eval pipeline. Understand the framework deeply before you build. Now you can see Claude has just finished writing our eval configuration files. It created both evals.config.ts and smoke.eval.ts. And now it's asking us to confirm before it runs the type check and eval discovery commands. We're going to go ahead and select Wiki yes koyas to let it verify that everything compiles correctly and that Eve can actually find our new eval. This is a really important step because it catches any TypeScript errors before we ever run a real evaluation against our agent. Now, we're at a really interesting decision point. The agent has set up our eval scaffold successfully, but it's asking us how we want to handle model access. You can see three options here. Start with a deterministic mock model first, wire up a live model, or just drop in an API key. We're going to go with option 1, the mock model, because it lets us run ev-eval instantly without needing any credentials. Perfect for validating that our eval pipeline is wired up correctly before we bring in a real model. Now you can see Claude has successfully scaffolded our eval project. It's created the full directory structure with agent.ts, evals.config.ts, and our smoke.eval.ts file, and it's even pulled up the Eve docs on cases to make sure everything aligns with the framework's conventions. The one thing Claude is flagging is that we don't have model credentials wired up yet, so it's actually pausing and asking us how we want to handle that. Do we connect to live model or keep things generic for now? This is a great example of the agent being transparent about blockers rather than just guessing. So let's answer its questions and get this thing running. So right now, we've got Claude working inside the Cursor IDE, and you can see it's actually reading the Eve documentation on the right, while simultaneously setting up our eval scaffolding on the left. Pretty cool multitasking. It's just run a Vercel humi command to check if we're already authenticated, and it's asking us whether we want to proceed. We're going to go ahead and hit 1 to confirm, which lets Claude continue wiring up the live model credentials so our evals can actually run against a real agent. So at this point, Claude has walked us through the full eval vocabulary. You can see it's explained t.succeeded, t.check, t.judge, and t.judge.autoevals right there in the terminal. Now, we need to run npx evlink to connect our project to Vercel, which is going to pull in that AI gateway API key into a local .nve file so our evals can actually hit the live Claude Sonnet model. Go ahead and type that command in your terminal whenever you're ready, and once it's linked, we'll fire off npx ev-eval to get our first green run. So here we're running npx evlink to connect our Eve agent to Vercel, but you can see it's throwing an error. It can't list Vercel projects in the Robert Mill scope. What the AI is doing now is actually reproducing that failure directly by shelling out to Vercel project ELS, format JSON, scope Robert Mill, so we can see exactly what's going wrong under the hood. This is a great debugging pattern. Let the agent trace the exact command that failed so we know whether it's an auth issue, a scope problem, or something else entirely. So here we're running npx evlink to connect our agent project to Vercel, but you can see it's throwing an error. It's trying to use your personal account Robert Mill as the scope, and Vercel doesn't allow that. What Claude is doing now is diagnosing the root cause by searching through the Eve source code, and it's already figured out that we actually need to point this at our team scope BertMill 19's projects instead. So here you can see our AI agent, Claude running inside Cursor, is actively debugging why the evlink command is failing. It's traced the root cause down to the Segomaihi scope flag being set to Robert Mill, which is a personal Vercel account rather than the team scope BertMill 19's projects. We're watching it work through the investigation step by step, searching files and running shell commands so we don't have to do this detective work manually ourselves. So here we're running npx evlink to connect our Eve agent to Vercel, but you can see we're hitting an error. It can't list Vercel projects under the Robert Mill scope. We tried switching to the BertMill 19's projects scope using Vercel switch, but it made no changes, so we're running npx evlink again to see if that resolves it. This is a pretty common auth scope issue with Vercel's CLI, so don't worry if you run into this, we'll get it sorted. So you can see here we're running npx evlink to connect our project to Vercel, but we're hitting a recurring error where the CLI can't list projects under the Robert Mill scope. What the agent is doing now is trying a different approach. It already linked the directory directly to the team project Eve agent evals, and it's about to retry evlink, hoping it picks up those existing credentials automatically. So here you can see we're running npx evlink to connect our project to Vercel, but we're hitting a scope issue. The CLI can't list projects under the Robert Mill team. Rather than keep fighting that interactive flow, we're pivoting to a smarter approach, running Vercel NV pull to grab an OIDC token directly from the environment, which is exactly what the Eve agent framework needs to authenticate. This gets us around the interactive terminal limitation entirely and pulls those credentials straight into our .env local file. So here we can see Claude running inside Cursor as an AI agent is trying to link our project to Vercel using npx evlink, but it's hitting a scope error because the CLI is defaulting to a personal account instead of our team. What's really cool is watch how the agent doesn't just give up, it pivots, tries Vercel switch to change the active scope, and then retries the link command automatically. This kind of autonomous error recovery is exactly what makes agentic workflows so powerful for real development tasks. So right now, you can see Claude is autonomously writing our eval files. It just created deterministic check.eval.ts and judge.quality.eval.ts inside the evals basics folder. These cover 4 key evaluation patterns: deterministic string matching, LLM-as-judge for fuzzy quality, and both gate versus soft severity modes. And now it's spinning up a shell command to run the full type check and eval suite, so we can immediately verify everything composes and passes before we move on. So here we're looking at our deterministic check.eval.ts file inside the Cursor editor. This is where we define a simple eval that sends the question, what is 7 times 6, into our assistant, and checks that the reply contains 42, using that includes matcher.